All right. So chapter 1, section 1, points, lines, and planes. So those are kind of the three main topics that we're going to be talking about. We've already talked about what makes a point, a line, and a plane. We're now just going to talk about kind of the nitty gritty of it as to how to illustrate it, first of all, which I think we'll be pretty good with that, but also how to label it in context in a problem. So if I wanted to say, hey, I want this line, what different ways can we name it based off the information that we know? And the things we're going to use are like the points that are on the line, the name of the line, where the line's located, things like that. Now, this is going to become very important as we progress through the curriculum because we're going to want to reference certain things, and whether or not we have symbols with the names or things like that, it'll let us know what we're talking about. So the first thing I want to talk about is just a point. And again, we've already kind of talked about this before, but a point, it has no size. So again, it's a specific location of something. It exists, but it's so small. It's so infinitely small that it has no size to it. It just has a location. So again, no size, only a location. Now, we've talked about points on a coordinate plane. That's when we have the X and the Y, when we're talking about an X and a Y axis. For this, we're just talking about a point that exists. It doesn't exist on a coordinate plane. It just is a point. Now, again, with the points, lines, and planes, we're going to have a way to name it. So when I write the word name, I am going to be explaining what would be like the notation for a point. So if I wanted to say I have point A, how would I write that? So whenever you want a point, it's just going to be a capital letter. So if I want a point, I'm not going to say, hey, I want point lion. It would be point L or point A, point B. So if I want to have point A, I would say that it is point A, or I might just reference it as a capital letter. But just saying it's point A, that means that it has some sort of location and it exists somewhere. So that's our example of saying point A. And again, it might just be a point, and then it will be the letter A. Next up, we have line. Now, a line, we know what a line looks like, but mathematically, what is a line? Now, a line is going to be made up of points. It's an infinite number of points, meaning if a line exists, you can find points along the line. In order to create a line, we have to have at least 2 points because you have to have a point where it goes through and another point where it goes through. If you could imagine, if you just had 1 point, the number of lines that could go through point A would be infinite because we could have a line that, let's say, starts off as horizontal. It just goes straight across. And then if we take that line and then we tilt it up just a little bit, that's another line. And tilt it up a little bit more and more and more and more until it becomes vertical. And then we can keep rotating it around. We can just keep creating lines that go through this 1 point. But as soon as we create a second point, now that line is anchored and it has to go through those 2 points. So now it can't be moving around because it has to go through those 2 points. So I'm going to go ahead and write the book's definition of a line, and then we can maybe paraphrase it if we need to clarify it at all. So the book's definition of a line is it's made up of points and has no thickness or width, and exactly 1 line through any 2 points. So that's the definition I'm going to go ahead and write, even have the textbook so that I don't mess it up. And if you don't like that definition, you can always write something else. And so I'm going to go ahead and give my definition after we write this down, which might be a little bit easier, or maybe it's the same thing in your mind. So it's going to be made up of points and has no thickness or width. And there's exactly one line through any 2 points. So again, just to kind of break down what this is saying, is that a line made up of points. So you have to have a bunch of points on a line. Now, when it says it has no thickness or width, that means that when we draw a line, that has a thickness. It has a thick line. In fact, I can go through and I can change my thickness to having a smaller line. So I can see that between these two lines, there is a certain thickness to them. Now, mathematically, theoretically speaking, a line has no thickness, meaning you can't see it. The more you can see, the more points that would be almost collected on this line. So mathematically speaking, lines shouldn't be visible, because if you can see them, that means that they are thick in some way, and a line has no thickness. So we're living in a theoretical situation, but obviously we need to represent it in some way. So that's why we draw lines. Well, underline thickness, because that's where it's going to stay. I see what game you're playing. I moved off my marker onto the line. All right, to name a line, I'm going to go ahead and start off with a picture of a line so that we can reference that picture so that we can successfully name it. We're going to have A, point B, and a line that goes through those 2 points. I'm also going to give it an overall name. I'm going to call it M. All right, so it was created through 2 points, and I'm giving it a name of M. Just made that up. And so again, if you're creating your own definition for a line, you can just simply say that a line exists through 2 points, and it may have a name. So since there's some components to this, there are different things we can call it. Kind of like all of you at home, you may have a name, but you may have other things that you are called. You can have a first and last name. You can be referenced by the last name. You could have a nickname. You could have a middle name. All those names are still you. So a line is the same sort of idea, that it has a lot of components to it. So we can call it by different names, and it all means the same thing. So the first way that I am going to name it is by the name that I gave it. So I can call this line M. If I say line M, I know that I'm talking about this line right here. I can also call it line AB, because those are the 2 points that are on the line. I can also just name it AB, and then I have to add a little symbol on top of that so that I know that it's a line. And I'm going to do that by drawing a line on top of the AB. Now that is very, very important, because if I didn't include the arrows, then I would have a line segment AB, which would say that it would stop and it wouldn't go forever on both sides. So if I had just this, that would be AB, but without the arrows. Since I have the arrows, I need to include the arrows in my name. So I can call this line M. I can call it line AB. I guess I could even call it line BA if I wanted to. And then I could also just write AB with an arrow on either side of the line above that. And I don't really need an example because I already drew one. Right, any questions with a point or a line for now? All right, we have one more and then we'll start talking about the relationships of them. And that will be a plane. And again, we talked about this last week. The thing about planes is that they go on forever in every direction. So they go up, they go down, they go left, they go right, in every other direction we can imagine. They are completely flat, so they are two-dimensional. This smartboard could be an example, not an example, but a representation of a plane. It's not a plane because it stops, but it's a flat surface that allows me to draw things like squares and triangles, and then we have certain properties that are affected by those. We did talk about how there being different planes out there. If our plane was curved a little bit, then it would be a spherical plane, because if that just goes right around into a sphere. But we are not going to get to that. We are only sticking with these flat surfaces, kind of our Euclidean plane. All right, so I'm going to go ahead again and write the definition, the example that's in the book. I'll read it to you before I write it down. A plane is a flat surface made up of points that extends infinitely in all directions. There is exactly one plane through any 3 points not on the same line. So a lot of words in there, write it down, and then we'll kind of clean it up a little bit. So it's a flat surface made up of points. So again, kind of like a line is made up of points, a plane is made up of points as well. Now, even though we're only labeling a few of the points, that doesn't mean that there aren't more points on the plane. It's just the ones that we're talking about. All right, so a flat surface made up of points that extends infinitely in all directions. There is exactly one plane through any 3 points that are not all on the same line. Now, what's the importance of that? So all the points are in existence, but they're not on the same line. Because if you had them all on the same line, then again, they would have no thickness because they're just a line. Now, if a line has no thickness, then it can't extend in all directions. So these 3 points have to not all be on the same line. And if there exists 3 points that are not on the same line, then they can form a plane. So what would that look like? So I'm going to stick with the shape that we have on the worksheet. They're doing a parallelogram. And I'm going to name this plane. Sometimes they like to use cursive letters because if you were to use the normal letter of our normal penmanship, it may look like a number. So I'm going to give you an example where that is happening. It is a cursive L. Now, it is not a very good L on the smartboard. I'm going to exaggerate it. There we go. So the reason why I did that is if you can imagine a lowercase L might look like a 1. So they're trying to help us out, and so sometimes they use cursive letters. And if you're ever not sure what, because I don't really know what people's background is with cursive, so if you ever aren't sure, just let me know and we can go over that. Oh, so the book is saying a capital script letter or letters naming 3 points, yeah. Yes, it is supposed to be capital. Thank you, Ms. Warninger. Cursive L. All right. Should have just done that. So that's a capital K. Looks the same. Of course. All right, so here's my picture, and I can see that this A, B, and C, if I try to connect it, it's going to be bent, which means it can't be on the same line because lines can't bend. They can't go in angles. If anything, this would be 2 lines. So I can definitely say that A, B, and C are not on the same line. And we're calling it the capital K. So the ways that we can name it, we can just say that it is plane K. Again, that is a capital K, obviously. And the other part of the definition is that it's through 3 points. So since there are 3 points on the plane, I can also call it by those points. So I can also call this plane A, B, C, because those are the 3 points that are on there. What's kind of nice about this is that the letters can be in any order. Meaning I can have plane ACB, plane BAC, plane CBA, plane CAB, etc. So as long as you have the 3 points that make up that plane in any order, that could also be the name for it. Now, unfortunately, there isn't kind of a cool little symbol like a line where you could say AB and then drew a symbol on top. With a plane, you have to write the word plane and then what letters make it up. It's also fortunate that sometimes the order does matter, but in this case with planes, it doesn't. When we get into angles, then the order will definitely matter. And that's where people start to get a little frustrated with geometry, is that it's not really math, it's the notation and the understanding of what is going on. So that I will have to get picky with just because one thing means something, and if you switch around the order, it may mean something else. But for lines and planes, the order is not that important. All right, so now that we did our 3 vocabulary words, I want to talk about some of the relationships. Of things like points and lines and planes and what it means. So when I have 2 lines and they are connecting, what does that mean? And if I were to have 3 points that are on the same line, what does that mean? If they're not on the same line, what does that mean? So the first relationship I want to talk about is collinear. Now, linear means that it's going to be modeled by a line. So if something is linear, then there is a set pattern to it. That pattern does not change, and we can kind of predict where things are going because it's just in a straight line. If someone had a linear thought process in our language, what that means is that you can see where the thought would start and where it will end up because it follows that same pattern. That if someone were to get angry and they were to kick someone in the shin, then they're then going to feel pain, and then maybe they are going to want to kick them in the shin. That is linear thought because there's a set pattern to it as it progresses. So if something is collinear, it means that it's also on that line. So if I were to have 2 points on the same line, I would say that those points are collinear. So to be collinear means that when we have 2 or more points that are found on the same line. So like the example of a line, AB, A and B were collinear. Now to go hand in hand with collinear is non-collinear. And that's when 2 points are not on the same line. So like in the example of our plane ABC, A and B may be found on the same line. And I'm going to go ahead and redraw that example, just because I don't want to scroll up without people having the words. All right, so A and B. I could draw a line through A and B. And what that would tell me is that A and B are collinear because they are found on the same line. The fact that this arrow is solid means that it's right on top of the plane. And C is non-collinear with points A and B. So A and B are considered to being collinear. So A and B are collinear. And C is not collinear with A or B. So that's in this green situation. A and B are collinear. C is not collinear with A or B because it's not found on the same line as either. Well, what if I did something like this? Now by having a second line, line AC, I am now able to say that A and C are now collinear. And I can say that on that line, that B is not collinear with A or C. So depending on what we have in the picture and what line we are referring to. With the green line, line AB, A and B are collinear because they're on the same line, and point C is not collinear or is non-collinear with A or B. Now, I did change the way that I was writing it because non-collinear is the official name, but I think it makes a little bit more sense just to say that it's not collinear. So I don't care which way you write it. You can say that A and C are collinear and B is non-collinear with A or C, or I think it just makes more sense to use the word not instead of non. And in the blue example, A and C are indeed collinear. And in the blue example, B is now not on that line, line AC. So B is not collinear with A or C. So the question is it line AC or points A and C? So with this example, since it's just a capital letter, it's just making the reference of not being collinear with A and C in reference to line AC. So yes, that's why the notations start to compound of, if I just use only the notations, it can start to get confusing. The more words we add in and the more questions that are asked, the more that we can understand. Great question. Before you write this down, let me just double check on that spelling. Yep, I'm good. Coplanar, not someone that complains, but to be on the same plane as another point. So that's when points are found on the same plane. And then, of course, to go hand in hand with that is non-coplanar, points not found on the same plane. We'll use different letters. All right, so I'm going to give that capital letter R as the name of the plane. I wanted to give it the name because I only put 2 points in the plane. And if I'm going to reference the plane, I need how many? I need 3 points. So I only drew 2 points in there, point M and point N. And then somewhere else, I have point T. Now, because T is not found in my plane R, I can assume that T is not on the plane. Now, I know by definition, planes go on forever, but we are pretending that maybe T is just a little bit below the other plane or a little bit above it. It's just not on the plane. So a conclusion that I can make is that points M and N are coplanar and C is non-coplanar or not coplanar with points M and N. All right. And I messed up by doing lowercase letters again, so make sure they're uppercase. But as I'm labeling them, I'm making them uppercase. And I'm going to use the non-coplanar in this case just because I didn't earlier. So points M and point N are coplanar. Point T is non-coplanar. And I'm going to say with plane R. So now I'm starting to kind of confuse things because I am referencing certain things, but we can assume that if it's non-coplanar with R, that means it's also non-coplanar with every point that's found on plane R, which are points M and point N. So again, that's kind of the thing with geometry, is that it's all understanding from what direction we're looking at things and what it means. All right, we do have a little bit more to go over, but I want to take a little break and just try a couple problems and see how we are able to do. So I'm just going to go to that worksheet that's found in the classroom. So again, for anyone that showed up late, that's not sure where it's found, it's under the 1-1 assignment, under points, lines, and lanes. And I want to talk about just the first 3 problems. Because again, we haven't talked about intersection yet, and we also haven't talked about what an opposite ray is. In fact, I don't think ray is in this section, so we're probably going to skip that one. All right, so the first one, we want to name a line that is not contained in plane N. Now down here, you see their fancy little N. And so they want a line that is not on plane N. So that's what I mean by contained in plane N. Now I see 3 lines. I see a line right here. That could be line CB. I see a line here. That could be line CD. And I see a third line right here. That is AE. Now this dotted segment was not an accident. It is on purpose. And you may know what it means. And if you don't, what it's saying is that this line exists, but wherever it's dotted, it's not visible for some reason. And so what we have is that we have this plane and we have a line on top and a line on top. And then we have another line that's going straight through the plane. So a nice illustration is, let's say we have a piece of paper. We have a line that is going through that plane. Now, if we tilt it down, you can't see the other half of the pencil because it is below the plane, but it still exists. So what we say is that there's now a dotted line to show that's going through the plane. We can't see it because the plane's blocking the view, but it's still there. And then it comes out through, and then down here, we can now see it again because this point and that point, A and E, form our third line of line AE. So name a line that is not contained in plane N. Well, line CB would be contained because it's right on the plane. So we can say it exists within the plane. And since the line goes on forever and the plane goes on forever, the line will never leave the plane. Same thing with line CD. As it goes on forever to the left and to the right, the plane is also going on forever. So that line is in that plane, right on top of it, and it's going to go forever. Now, the one that isn't contained is line AE. It's piercing through the plane, and it's not being contained in infinite directions on both sides. Name 2 different ways to name a plane that contains point B. Well, we said that we have 2 different ways to label planes. We can either say that its name, which is found in the corner, that capital letter, or we can name it by the points found on the plane. So 2 different ways to name a plane that contains points B. Well, the plane that contains point B is plane N. So that's the first thing that I'll call it. I'll call this plane N. By me saying plane N, I know that I'm talking about this image right here. Well, what's another way to call it? Well, another way is to reference at least 3 of the points found on the plane. It has points B, C, and E. So I could call this plane BCD. I could call it plane DCB. I could call it plane CBD, plane CDB, etc. So as long as I am including those 3 points in any order, then I can call this plane by that name. And lastly, name 3 collinear points. Again, collinear, meaning that they are found on the same line. Now, if I want 3 collinear points, then that means that I must have a line with 3 points on it. Otherwise, I can't answer the question. And so this line right here has C and B. So that can't be my answer. This line here has lines C and D. So that can't be my answer. So then this line AE must be my answer. Now, what you may notice is that it does have point A and it does have point E, but the point at where this line crosses through the plane is through point B. So this line actually has 3 collinear points because A, B, and E are all found on this line. Now, since we have 3 points, that also opens up to different names that we could have for this line. I've been calling it line AE. Technically, call it line BE as well, because that one line is, there's only one line that goes through 2 points, so AE is the same thing as BE. And AE and BE are the same thing as line AB. So this one line, because it has multiple labeled points, it now has multiple names. So again, line AE, line AB, line BE are all the same. And then this next word with intersect, I guess we don't really have to write it down in the notes. Intersection is wherever things cross. Whenever they cross paths, they are intersecting with each other. And so name 2 lines that intersect and the point where they intersect. So if we're looking for lines that intersect, then we're looking for lines that are crossing. And we have 2 situations where that's happening. The first situation is right here. We have line CD and we have line CB. These 2 lines intersect, and they intersect at point C. The next 2 lines that we have that intersect is going to be lines CB and line AE. AE and CB intersect at point B. So name 2 lines that intersect and the point where they intersect. We had a couple choices. First one was line CD and line CB, and CB and CD intersect at C. And then CB and AE intersect at point B. Any questions on that terminology? So the clarification is, so lines can intersect on a plane and the plane. That is correct. They can also intersect outside of a plane because they may be coplanar to a different plane. So we could also have 2 intersecting lines off to the side, and we're just saying that they intersect somewhere else off of that plane. But I don't believe that example comes up, but if you were creating your own, you could always do that as well. Speaking of creating your own, let's take a moment and try number 18. So this is the first problem on your homework. Mostly because I want to talk to the people in the room as well. So you people at home, what we're going to do is that I want you to try this problem. I'm going to take a look at what the people in here are creating. And then I'm going to go to my smartboard and I am going to do an example that could fulfill these requirements. That also means that everyone should have the first one done. And then we'll move on to the other 2. You can see, again, the terminology. Plane R contains lines A, B, and DE. They intersect at a point. This is add point C on the plane, so that is not collinear. You can see they're also using the not instead of non with that. So you have all the information you need to do these problems, but let's just try number 18. So again, I would like you to draw this diagram somewhere. It can be in your notes on your own homework. And you are going to want to create 3 lines, lines L, M, and N. And you want to show that they are coplanar and that they all lie within plane Q. Now, when you go to draw that, also keep in mind that lines L and M should intersect at a point, that point being point P, and that line N intersect line M at another point, point R. But it does not intersect line L. So again, this is like a little puzzle. So I recommend that you do this in pencil because you might need to erase. I know that there definitely exists a point P and a point R. So maybe start off with those points and then try drawing these 3 lines so that you have 2 lines that intersect at P, 2 lines intersect at R, but line N does not intersect with line L. All right, so the best strategy I have for you is just to try this, see if it meets the criteria that you need, and if not, go back and then just try to modify as you'd like. So I'm going to mute myself and see if people in here need help. And if anyone has any questions, feel free to send it into the chat. So let's see if what you have works for something here. So I recommended starting off with point P and point R before drawing the lines. So I'm just going to put over here point P and over here point R. All right, so I did those two. Now it says that lines L, M, and N are coplanar, which means that when we draw the lines, they should just be in the plane. They should be right on top. They should be within this parallelogram. So there's nothing I can do yet. That just means that I can't have like line L be over here. Can't do that because then it wouldn't be coplanar. Lines L and M intersect at point P. So that means that line L and line M have to cross at some point at point P. So I'm just going to draw it. I don't know if this is right or not. I'm now going to use that cursive L and then also line M. So I'm going to draw another. I got more colors. We'll do green for line M. All right, so lines L and M intersect at point P. Check. Line N intersects line M at R. So if it intersects at point R, that means that point R must also be on line M. So I'm going to go ahead and take my eraser and erase this here. And I'm going to now rewrite point R so that it's found on line M. So I drew my point R incorrectly, but I was just trying something, all right? Now that I know that point R is going to be the intersection point of M and N, I am now going to draw line N to be intersecting through line M at R. Okay, let's do a different color. We'll do this color. So now I want line N. And so I'm just going to draw line N, and I'm going to say it intersects. So I'm going to go ahead and do this. All right, so now I have line N that goes through point R and intersects with line M. So I'm going to go through and just read through, make sure everything is good. So line M, L, M, and N are coplanar. Yep, they're all on the same plane. They lie in plane Q. Yep, they do. Lines L and M intersect at point P. Check. Lines N intersects line M at R. Yep. But does not intersect line L. Well, shoot, I made another mistake because this N is going to cross through, and at some point, since those arrows go on forever, line N will intersect with line L. So I'm going to have to erase it, but I have to think to myself, well, what type of lines never intersect? Well, they can't be the same line, obviously, because they'd be intersecting everywhere. And if they slant at all, then they're going to intersect at some point. So instead, what I want to have is a parallel relationship. So these lines should be going along almost the same track. If you imagine like railroad tracks, they never converge. They have to keep the same distance away because then otherwise the wheels will obviously come off. So then my picture that I'm going to finish with is going to be line L and line N are parallel. So they're never going to intersect. L goes through P, N goes through R. And in between points P and R, they're both going to be intersected by line M. So the answer to the first problem would have some sort of variation like this. Now, is this the only right answer? No. Does it have the same components as every right answer? Yes. I'm going to have the same points, and it's going to have to be some sort of parallel relationship. Another thing that would have answered this is if you had like the letter H. Think of a capital letter H. That would be the same thing as what I have here. I just have the H kind of tilted. All right. Any questions with this creation? All right. Now the next two problems are going to be kind of the same deal. You want to complete the figure at the right to show the following relationship. So 19, you have plane R. Notice how this plane doesn't have a label, whereas this one did. That means you're going to want to label it. And it contains lines A, B, and DE. So there's that notation, switching it up. Notice the arrows on both sides. Now those two lines are going to intersect at point P. So you want to kind of start with point P and then show the intersection. Then you're going to add a point C on plane R. But you want to make sure that it is not collinear with either line. And then the last one, you want to draw and label a plane Q that satisfies each relationship. So they already gave you the Q. And you have line AB is in plane Q. Line ST intersects line AB at point P. You have point X is collinear with points A and P. Point Y is not collinear with points T and P. And line L contains points X and Y. So once you find your X and your Y, which you had to put here, you're just going to label that point line L. All right, so again, it's like a little puzzle, and you want to make sure that all criteria are met.